I do that. All right, two-way tables. I'd almost guarantee you've seen these before in some ISAT-like test question or something like that. It's a table of counts that summarizes data. On the relationship between two categorical variables for some group of individuals. Yes, sir. There we go. We both did okay, huh? Right. So in the book, you don't have to look in the book, but in the book they have this as an example problem, I think. Environmental club members or member Now, if I was writing a book, I would never use a word as long as environmental. I'd say like Key Club or something like that because I'm lazy. We have no, and we have yes. And snowmobile use is the other topic. And in those categories we have never, rent, own, and that's it for the moment. So this is now the fourth time I've given this lecture. I think I'm going to change some things here a little bit because in the book they use these really large numbers. So I'm going to make this a little bit simpler. I'm going to say 45 said no, they're not an environmental club member and they've never ridden a snowmobile. 50 say they rent sometimes, but they're not in the club or not in a club. And 28 own. So again, if you look in the book, the numbers are going to be different. But for notes, this makes life easier. Yes, we have 22. 22 are in the club but have never owned or never ridden a snowmobile. 8 are in the club and they've rented a snowmobile. And 2 are in the club and they own. This right here, these numbers in here represent all the people in the study or in the questionnaire, and we call these joint frequencies. frequencies. So that's your sort of your raw data, kind of like your raw data, if you will. Now we have total. We actually have two totals, total here and total here. So let's see, 45 and 50 is 95, plus 20 is 115, plus 8 is 123. 22 and 8 is 30, plus 2 is 32. And now I have 45 plus 22, that would be 67. Correct me if I'm wrong, please. I'm not double checking with the calculator, I'm just using my head here. And as you'll find, my head is not necessarily reliable. So it looks to me like we've got 155 total. I'm going to call this the grand total. This is sort of my term. But these guys are called our marginal frequencies. These totals are marginal frequencies. So we should get the same number. I added the 123 plus the 32 to get the 155. But if I add 67, 58, and 30, I should also get 155. And if I add all of the joint frequency values, I should get 155, assuming that I did all the math correctly. Did anybody double check me? No? All right, good enough. Don't double check the teacher, he might get mad at you, right? Okay, no, I'm kidding. I don't get mad for stuff like that. So, what do we do with that stuff? Well, there's a few things we could do. We can find the marginal relative frequency. When you see the word relative, I want you to be thinking percent. Percent is a way that we can compare things in a relative sort of fashion. So relative frequency, we're going to do something with percents. This turns margins into percents, or marginal values. In respect to the grand total. So I'm not going to fill everything in, but I'm going to kind of just make a quick sketch of what we already have here. So we've got 155 here. That represents our 100%, or 1. So what we would do is we would take, to calculate our, let's see, I need one more here. To calculate our, we'd take our totals, 67 divided by 155, and 58 divided by 155, and 30 divided by 155. And I'm going to play with the calculator here for one quick second. This is 0.432 about. This is about 0.374. This is about 0.194. Now, if I add all of these decimal values, these are percents. In statistics doesn't care if you write it as a percent or write it as a decimal. In my opinion, the more steps you take, the more opportunity you have to write something incorrectly. So I tend to stick with the decimal, but I do flip back and forth. So these are seen as percents. Now, that would be for our never, our rent, and our own. Now, what about the no and the yes? Well, we do the same thing. So our no total is 123 divided by 155. And the yes total was 32 divided by 155. So those values, about 0.794. So those are our marginal relative frequencies. It's taking the marginal totals and writing it as a percent relative to the grand total. Pretty hard mathematics there, right? We're in over our head already. Yeah. It's not the math that's tough in this class at all. You may have a situation where if you add these up, it looks to me like this wouldn't be the case, but if you added these up and got like 0.99, that's okay. That's called rounding error, and that's totally acceptable in math. Could be a little bit higher than 1, 2, or 100%. Same thing could happen here, but I think in this example it actually works out to where if I add these and I add those, I get either 100% or 1, right? Yeah, but sometimes you'll get less than or more than, and that's okay as long as it's not a lot less or a lot more. If you get 95% when you add them all up, that's not acceptable rounding error. If you get 99.9% or something like that, or 99.7%, you're good. All right, let's move on. Next thing is joint relative frequency. And the joint relative frequency turns joint values into percents with respect to the grand total again. If there's a special term for that grand total number, other than grand total, I don't know it. Probably somebody in here may actually read the book and see that there is a term for that and embarrass me for not having read the term. So just letting you know, I'm imperfect in every possible way. So the joint relative frequency would look like this. No, yes, never, rent, own, and we're using our 155 here. So no and never would be 45 divided by 155, and we get some percent for that, or decimal. And the yes would be 22 out of 155. And then we have 50 divided by 155. I won't get the decimals for you. I think that's wasting your time. I think you can do that if you need to. And then we would have the 28 and 155 and the 2 and 155. So we would turn those into decimals or percents. Any guesses as to what that would add up to if I added all those percents up? 2? 1. 1. Would be 1. Yeah. Because if you add all of these numbers together, we should get the 155. So the 155 comes from adding all of the joint relative frequencies. So yeah, that total percentage in each of those 6 columns, or 6, what do you call them, boxes, should be 1. All right. Those are pretty straightforward. The tricky one is the conditional. We've got a conditional, relative, frequency. The conditional relative frequency, again, the math's not hard. It's trying to understand what's being asked of you that's tricky in this class. It turns joint relative values to percents with the respect to the categories. Actually, I don't think I need to say relative values. I think just say joint values to percents. Let's say to the category totals. I'm going to say rows or columns. We don't do this with both. I mean, unless it's asked to be done with both ways. We'll look at it one way or the other. So, if I were to do the row, it would look like this. No, yes, never, rent, own. So for our rows, what do we have? We had 45. This would be 45 out of 67. And 22 out of 67. And the total is 67. So in this case, these two percentages should add up to 100% of all of the responses for this category of I've never ridden a snowmobile. Does that make sense? So that becomes 1 or 100%. The next one, what do we have numbers wise? 50 divided by 58, that's going to turn into a percent or decimal. And 8 divided by 58. And so 58 being the total, but that's going to end up being, again, 100%. These two added together will give us 100%, and so forth. So 28 over 30, 2 over 30, total being 30 over here. Again, 100%. So row, same thing with column, except it's vertical. We've got no, and we've got yes, and we've got never, rent 'em, own 'em, and I have a total of 123 here and a total of 32. So this no and never is going to be 45 divided by 123, and 50 divided by 123, and I think you guys have got the idea. Over here we're going to have 20 2 divided by 32, and 8 divided by 32, and 2 divided by 32. And those all turn into percents. This would be 100% of the no's, and this would be 100% of the y's. So again, we would turn those into decimals. You could have rounding error. That's totally okay. Remember, it's the science of approximations. I have one other thing to hit you up with. So I try to pass on life lessons as much as I can from my life. That way, hopefully, you can avoid them in your lives. There are always two people in the world, two kinds of people. There are people that only learn by experience, and people who learn by, what do they call it? By watching others make mistakes. I try to learn the second way, but sometimes I have to learn the first way. I think we all do. But one of the things that I would highly recommend you guys to do in your lives, as the need arises, is get to know your insurance agent for a couple of reasons. Basically, if your house burns down and you've got homeowner's insurance, it's good to be able to sit down with the person and go, hey, guess what, my house burned down, and have a relationship with that insurance agent. Danny is my insurance agent. He's been my insurance agent since I moved up here. And Danny's a great guy. He's a few years younger than me. We've been through some of the same kind of life situations. He's an economics major. He's got a couple of insurance, what do I want to say, a couple of insurance businesses. Same company, but a couple different locations. So he's really successful. And a couple times a year I go in and I pay him money and I gripe about it, and we usually sit down and talk for a couple of hours. Not about insurance. We'll talk for maybe 4 or 5 minutes about insurance, and the rest of the time we're just talking because we're basically friends. And so I know that if anything ever happens, I'm going to have Danny covering me as to the best of his abilities, versus somebody on the phone that doesn't know who I am and really doesn't probably care that much. They sound like they care, but maybe they don't. I mean, it's, you know, they don't know my kids' names or anything like that. Danny does. And I know his kids' names. So, anyway, Danny was telling me once, being an economics major, they looked at a lot of statistical situations. And I can't remember if they did the analysis or if somebody else, they were studying an analysis. But somebody asked a questionnaire that had 2 questions. One of them was, how often do you eat hot dogs? Or, you know, how much do you eat hot dogs? You know, I don't know what the answers were in the categories or what, if it was numeric or whatever. And the other question was about health. And it turned out that people who ate more hot dogs were more likely to have lung cancer. Wait, eating hot dogs causes lung cancer? Well, that's what this study sort of indicated. There was an association between the two. Now, does it make sense that eating hot dogs would cause lung cancer? I could see stomach cancer, intestinal cancer, maybe even leg cancer. I don't know where that stuff goes, but I don't know about lung cancer, right? I don't think so. I don't think that's it. I think it's
the fact that they use the pluck to make them.
See, you're trying to assign the hot dog as being the cause of the lung cancer. And I don't think that's it at all.
They use the lungs, so refer to as the lungs and stuff like that. So they're almost got the retail cuts, and they put
Right.
it as.
So eating pig lungs, you think maybe causes lung cancer in the person eating it. That's
Not
your...
necessarily causes it, but simply because it's the same organ. It could be thought, there's really no relation. Like, it doesn't just give it to you, and if you cook the hell out of it, it's been through. Probably worse than if you ate it raw.
Well, I have a thought. Let's see what these...
What if what gave them lung cancer makes them crave hot dogs?
Okay. All right. I like that. lifestyle choice. If you're a smoker, it's been proven that your incidence of lung cancer is much higher than somebody who's non-smoker. There's no question about that association. Would you guys agree? Scientifically, they've proven it. That's why you don't see cigarette companies advertising anymore the way they used to. So I think you're right. I think what happens is being a smoker is a very expensive habit. Depending on how many packs a day, I don't know. I hope you guys don't know. I don't even know what a pack costs anymore. I think it's near $5, maybe even a little bit more. Yeah, I'm sure, depending on the state, but it's expensive. So somebody who's spending a lot of money on smoking probably has less money to spend on protein. And hot dogs are a cheap source of protein. So if you eat more hot dogs, you're more likely to be a smoker, hence you're more likely to get lung cancer. So it's not the hot dogs that does it, it's the life choice. Good answer. So association, when we're thinking about association, I want you to think back to this. I'll use this reference a lot. Hot dogs and lung cancer. Do they cause? No, they don't. Another comment that I want you to write down and sort of put into your memory is correlation, which is like an association. Correlation does not suggest causation. Just because the numbers say that there's a relationship, some association, that does not necessarily mean that one causes the other. So be careful about that. It's the hot dogs and the lung cancer. Yes, sir.
Wasn't there a study done when like polio epidemics and ice cream was causing kind of the same thing?
Yeah, I think somebody was mentioning that, and I think it has to do with eating ice cream and shark attacks or something crazy like that. If you know, when ice cream sales are higher, shark attacks occur.